makeup data for the Crazy Ball Mystery Lab. I got a ball here and a ball here, and you'll see you have to make some observations and some inferences. So what I'm going to do is I'm going to drop these from about a meter high, and you're going to see them enter the screen. Try it again. You'll notice that one, and then here's the other one. Okay, so that was this one on the right. Here's the other one. And together, from a little lower though. Okay. So you're going to write your observations and why you think that happens over here. And then we made some additional observations in class that are going to be a little harder for you to do, but I'm going to give you some data for that. So ball A measurements, bounce height. Ball A is the ball that did not bounce. So the ball that did not bounce. And ball B is the ball that did bounce. So let's just go through the ball that bounced. I'm sorry, did not bounce. Bounce height return when it came back up was about 3 centimeters or so. Its mass in grams. Okay, let's get the ball that doesn't bounce. 10 grams. So you can write that down, 10.0 grams. And then its volume. We used a graduated cylinder to do that. What I'm going to do is tell you the starting and ending water volume. So what we did is we put about, you could choose, but let's say we put 30 milliliters in there, and the ball and the volume when you drop the ball in, okay, it's the ball that doesn't bounce. We drop the ball in, the water rose from 30 up to 38.0. So I'll let you calculate that volume of the ball yourself. So in here, when you had the graduated cylinder, we put about 30 milliliters in, 30.0, and it rose to about 38.0. So I'll let you figure out that volume here. Okay. The ball that bounced, okay, its height of return was about 40 centimeters. The mass, so let's just figure that out right now. Maybe I didn't show you before. 9.2. Okay, so 9.2 grams. And the volume is the exact same volume as the other ball. Okay, so it has the exact same volume, which is, so I'm not going to answer it, but it's the same exact volume. Okay. Now, I ask you to make a calculation. You can actually calculate density of the ball. I know we haven't really covered what exactly density is, but density is equal to basically mass divided by volume. Okay, and you'll notice for each ball you have the mass and you have the volume. You divide them and you'll be able to figure out the density. The units, you took mass in grams and you took volume in milliliters, so it was really grams per milliliter. So when you get your answer here, it's grams divided by milliliter are the units. Okay, and you're going to get the density of each ball, and you'll probably find that they're slightly different. Okay. Now, based on that, and by the way, density is basically how much mass something has if it is a single milliliter. Quick visual. The blue cubes that we've been using in science, those are a milliliter or a centimeter cubed, remember? So when you figure out the density, it's like cutting a chunk of the ball out that's that big and figuring out what its mass would be. So if I could make the ball this big, what would its mass be? That's what density is. So you're figuring out how many particles are packed in something as long as it's all the same size. So based on that, I'm hoping that your initial inference might change a little bit, so you can copy your rewrite your inference based on what you learned about the density of the ball and some of the other observations you made. And then here you just copy down the measurements I gave you, and you're going to do the metric conversions over to the right.